So I'm going to go ahead and welcome our special guest speaker today, Jeff Lindsay, and I'm going to go ahead and read his introduction here. Um, Jeff Lindsay is an independent open source creator known for technologies and software primitives that have directly or indirectly changed how we build software, from webhooks to Docker. There goes my notes. His pioneering work is motivated by realizing software as the ultimate medium of imagination. So take it away, Jeff. It's all yours.
Cool, thanks. And I wrote that, by the way, my bio.
I didn't want to
Yeah,
make
so
you read it by yourself, though.
yeah, thank
Thank
you.
you.
So yeah, my name is Jeff. I've worked on a lot of things. I worked on the prototype that became Docker. I was an early employee at Twilio. I pioneered or invented webhooks. I've written a lot of open source software, kind of all over the place, just kind of seeing what's new. And I'm really just kind of fascinated by the power of being able to create software. It's like pure creation, or it's pure imagination. um, and it's one of the things that makes the computer kind of the ultimate tool. Not only is it a tool that can become any other tool, it's really only limited by your imagination. It is an imagination compiler. So I was going to talk about some of the work I've been doing for the past few years. It's actually been for 4 years. It's gone by a lot. But in this time, which I've been funded by myself as well as sponsors, and you guys are actually all sponsors. So the ultimate goal is trying to build a sort of, I describe it as a Photoshop of software. Really a design tool for software. And I don't mean apps, because apps are, just one sort of manifestation of software. There's all kinds of software that, you can think of: command line tools and distributed systems and platforms and embedded, and, all these different kind of domains and ways that software exists. It's not just the stuff that, uh, average users, average consumers use. So this talk is kind of just broken up into a couple of sections, because it actually would take too long to talk about everything, that all the problem spaces that I'm thinking about, and all the prototypes and everything that I've been building. But I'm actually going to talk about a couple of ideas or references, and then towards the end get towards some concrete projects that you all might find interesting. So I'm going to start with, let's get this going here. Can you all see the slide full screen here? So we'll start with Unix. So it all goes back to Unix. Unix was invented at Bell Labs as well as C. They're kind of made for each other. And not only is sort of Unix the basis of pretty much every computing platform we have, even if not, a direct descendant of Unix, which actually a lot of them are, the ideas there, the abstractions that they created have endured. So things like, the shell, the concept of a shell, just being able to kind of, instead of just write programs and get the thing to use it, you can actually kind of move around. Like the file system itself was an abstraction that they had to create, as well as pipes, which is pretty popular thing to say as a Unixy thing. But I don't know how many of you know this, but they made a sequel to Unix. Does anybody know what this sequel to Unix was? Made in the 80s. I don't know if I can actually chat while I have this open.
Go for it, Jordan. I know you want to say it.
On the Plan 9.
Yes, exactly. Thank you. So Plan 9 from Bell Labs was basically a kind of leaning into the ideas of Unix, and they were able to refine a lot of the ideas and really simplify a lot of stuff. And it's actually quite amazing and elegant to kind of study. And I want to talk about a couple of those things. And one of the main ideas is that the file system is sort of the main abstraction. So they really leaned into the file system. Almost everything you do on the system is done through kind of working with files or doing read-write streams on what look like files, which, you know, we think of files as like this is a file on a disk, but they're talking about a file system as an abstraction where a file might represent an IO stream of some kind. And so this gives you some interesting kind of emergent properties that just simplify things. So as some examples here, some of you might be familiar with the proc FS that's in Linux, in which you can ls/proc and you see all the PIDs that are running. If you ls into one of those, you can kind of see various properties. And so that's, you know, an example of, you know, it's not really, you know, files on disk, it's information about the system that's exposed. This is how you did most things. So the equivalent here, and so this is all from a manual that had or a book that kind of has the semicolons as sort of their, that's not what the prompt looked like, but that's basically input when you see the semicolons. So this is some plan 9/proc is there. You can get whatever your current PID is and look at what's in there. And then if you wanted to kill something, a common pattern, it was to have a control file for something. And so you just kind of write a command into that file, and then that would perform the operation. So instead of having a separate command, a separate, you know, syscall or whatever, really most of the syscalls in Plan 9 were file operations. So there's only like 40 syscalls in Plan 9. They could do most things with those. So echo kill would kill a process. You even had the environment, you know, it was actually a root thing /env. You'd see the current environment. I'm kind of glad that they actually started just using your lowercase names by convention there. And so you can see the echo user as well as cat env user, and it's the same thing. More interesting stuff is the networking. So anytime any TCP socket was opened, it would show up here. And actually, if you wanted to open a TCP socket, what you would do is you would open nettcp clone and give it some parameters. You know, it's almost like sending it a command, and then it would return a number for you. And then that number would be the open connection. And then those would have various files. You'd have every, you know, you'd have a control file. You could send, you know, close the socket. You had the data, which, so working with that is basically like working with a socket, send and receive. You know, you had a separate channel for errors, and then some other information, you know, there's state and the local and remote address and stuff. So there's a lot of the mouse input or you know, the mouse position, obviously like console, keyboard input, audio, everything was done and exposed through the file system. And so you could kind of do everything from the shell. And a lot of what Plan 9 was shell scripts, because it's just working with the file system. On Linux, Unixy systems, you have a path environment variable where this would, you know, where it looks for the commands that you want to run. They also had a path, but there was usually only a couple things in it. It was the current directory, which great idea, and /bin, because everything else they would bind. So they had bind as a kind of a first class operation on this file system, which was kind of like a really cool symlink. But it could also kind of do these overlay things. So you could just take a bunch of bins and then kind of bind them all to the same place, and then you'd have the aggregate of those contents. And so you can do this with like fancy file systems. It's just like a built-in concept, and so they really leaned into it in the design of things. Also, every process ran in its own namespace, and so a namespace is basically, you can think of all the file paths that you would have. And so anytime you start a process, you create a new namespace, almost like a root, almost like a Docker container. And every time you would start a new one, it would basically run a script that sets up that namespace, that sort of virtual file system. And it looked like this. It's basically a bunch of binds. And the binds with the hash letters, those are sort of the built-ins, the sort of like, system level file systems that you could then, that you'd mount. And then so this is used for a lot of things. So you could not only sort of use this as a way to sort of change what kind of capabilities a process has on the system, like don't expose network, don't, in the namespace that you give it, don't give them the network, and now they can't do stuff with the network. But it could also be used, so for example, the windowing system would multiplex the mouse and keyboard input. So the processes that are run in a window don't see the actual mouse and keyboard. They're seeing a version that the windowing system is providing, and it's listening on the actual mouse and keyboard input and then multiplexing it when a window has a focus. There's also the 9P protocol, which is basically like a network protocol for the file system. If everything's done over the file system, you only need one protocol. And this not only lets you do kind of traditional, like remote, mounting a remote file system, so like a file server or something, but you could actually do a lot cooler stuff. And I'm gonna play a little video here. Can you guys see this video? My YouTube here. So here they are using our CPU it's kind of like SSH. Except it's an SSH where when you're on the remote machine, its namespace is basically your local file system. So it's like you took your whole file system and took it to the remote computer, and the things that you run there are running against your local files using the remote system's resources. And so I'm not sure if you guys can hear that audio, because there's an audio bit that I want to share. You guys hear that audio? Okay, well then I'll have to just
describe
but
you might need to,
that,
Jeff, if you unshare and then reshare, but click the share like the
I don't
audio
know. I'll just describe
button.
what's going to happen. So while he's doing this on this terminal does not have speakers, but the CPU computer that he has does. So what he did is he mounted the audio interface of the remote CPU locally, and then he plays audio, and then it comes out the remote machine. So these simple primitives, you can do a lot of stuff with them. So unfortunately, Plan 9, because of Java, they kind of diverted all effort and ended to work on something else. I think it was Inferno. And but all the people that worked on it actually ended up working on Go. So it's kind of interesting. You'll see in the Go standard library, there's a lot of Plan 9 isms and a lot of Plan 9 thinking. It's one of the reasons why I really like Go. And of course, like there are ideas from Plan 9 that have made it to Linux and other systems. But unfortunately, it's not a practical operating system because it doesn't even run a browser. So it's like you can't really even use it as your daily like alternative operating system, unfortunately. So if only there was some way to get some of these ideas out. But now I'm going to talk about something else. So we can take a quick break and I can answer any questions about Plan 9 real quick before moving on. Where's my mouse? Now I'm going to make sure I can see the chat.
There's no raised hands at this moment, but I did see a question in chat that was asking if bind was similar to a reverse symlink, or maybe if you could go over
it's like
between bind and Plan 9. Yeah.
Like they didn't have symlinks, they just had binding. And so it was kind of like a hard link, except it would also do the union stuff. So it's just a more powerful primitive. overall. So I'm going to jump into Unity, talk about something totally different now. I'm sure people are familiar with Unity, the game engine. So it's a game engine and an editor. The idea of engines sort of started in the 90s. Games very complex. Most people would just kind of start over every time. Things were moving fast, but once you got into 3D stuff, it made sense to sort of try and reuse, maybe for one more title. id Software sort of popularized, and I think sort of the term engine. But Unity, which came out in the mid 2000s, was the first game engine that I can remember that was sort of successful, that came from a non-game development studio. It was sort of, they were created just to make this thing. And it was the first time I actually saw sort of a universal editor. And they had started getting these abstractions right for basically making ultimately any kind of game. First it was 3D, now you can do 2D games, and you can kind of use it for any kind of game now. And it's the same thing. I mean, this editor, has more or less not changed, and it looks overwhelming, maybe, but it's actually pretty simple. You can, of course, rearrange it however you want. So there's a project window, which is basically a file browser, asset browser. There's this scene view, which is kind of a preview of what the game would be rendered, but you have like inline widgets and stuff to modify things. And then the interesting thing is the hierarchy window on the left, which is basically a scene hierarchy of what they call game objects, and then an inspector on the right. And those two are basically connected. So I really like Unity. I've been kind of into game engines forever. And Unity has always been kind of my favorite. Unfortunately, the company is sort of going downhill, and so is the engine itself. But that's the perfect time to kind of steal all the ideas. And most of what Unity is done is not really specific to Unity. A lot of the same ideas of this kind of scene hierarchy and even the kind of component model that it has is in a lot of other engines or something very close. And so it's kind of, again, this convergence of like, here's a common model, because pretty much everything in a game that you'd make with Unity is represented in the scene hierarchy. And games can be very, they can be anything, right? And so to have a system that can kind of model anything, that seems like a good place to look for kind of a place for, an abstraction or a paradigm for building any kind of software, or building a design tool for any kind of software. So a lot of the time I say when I'm trying to build a Photoshop of software, I'm actually saying I'm trying to build a Unity for any kind of software. So really quick, I want to talk about the kind of object model, which kind of focuses on what's visually represented by the hierarchy and the inspector. So in the hierarchy, you have, we'll call them game objects. They call them game objects, which is separate from, like object-oriented objects. And objects can have a name. They can have some other stuff, but it's not really important. Game objects, they can have child game objects, but then they can also have components. So in this object here called model, there's basically two components on it, a transform and a bounce model. And so those show up in the inspector. And so components, have fields, methods, and kind of a UI panel. So they're basically objects. In fact, they're literally objects. We'll get into that. And they can reference other components and game objects. So they're kind of aware of where they are in the hierarchy. And ultimately, they are just kind of objects, in this case, C# objects. But really quick, the idea of components sort of is they're made to work together to sort of represent like both the functionality of the game object. You could almost think of them like mix-ins to the game object. But they kind of work together. So for example, to create this object here, this cube, it's got some mesh geometry, and that's here in this mesh filter component. And then it's going to actually render that in a certain way. So that has a mesh renderer and that pulls the data from the mesh filter. And then this green outline means as a collider, so it can interact with physics. And so that's the box collider down there. And when you add the box collider, it sort of automatically fits the collider to the shape of the mesh because it just looks at the other component. So these things kind of work together, and you can kind of add up, what something is. And then, like I said, it is literally just a sort of defined by a class in C#. And one of the coolest things was that, you just create fields on the class, and then they show up as fields in the UI. And if you were to just hit save, it would sort of live update the UI. So you can kind of get this quick iteration. And it gave you pretty nice, UI, and there's all kinds of extensions to sort of create new types. And so a lot of people, when they customize the editor for games and stuff, they would just do it through components. So components could just be simple data, but they could also be a facade to a whole complex system. But most of the time, components would just be glue. They're adapters, handlers that hook into the events and extension points of other components. So you could also totally redo the component panel totally separate from what the actual, you can kind of render whatever you want in there. And then the hierarchy is meaningful to components in that, so for example, the transform, which is, your point in space, rotation, scale, what it means to be a child object transform on a child object means you're relative to the parent. So components can use the meaning of the hierarchy for certain things. So this way you can create sub objects so that the parent object, you can rotate that and everything will rotate relative to it. So if you want to make like an arm, on a character model or something, you can have all the parts kind of move around together. And then the hierarchy could also be used by the user or the designer. So you can see the way games will organize, or these scenes, which are kind of like levels or whatever, are totally different. Like everybody has different naming conventions, and some people will use, you can have game objects that don't have components, that you just use them, in this case, they just use them as spacers or like, dividers, right? And so that kind of like, it's this interesting trading ground for the code and the user, which is a property that file systems have as well, right? Programs can make expectations on structure and names in the file system. But the file system is also something the user has control over and how they want to organize things. And that is usually a good sign of a good kind of like primitive or abstraction in computing, at least. So that's Unity. Any questions about Unity? These things might end up making sense how they're connected.
Looks like we're good.
Okay. No, I'm customizing. Yeah. Some of you use Unity. So Manifold is kind of the thing that I've been working on for a while. I've been working on a lot of things, but this is sort of like the core primitive. And so it's why I've sort of worked on it the longest, and I've been pretty protective of it, and have rewritten it and redesigned it, almost a dozen times. And it comes up in many forms because the whole idea is you can use it in many different ways, but it's basically a generalized Unity object model. So this was back in 2020, I did this prototype. Already it looks kind of like a Unity or something like that. You've got a hierarchy, and then you have an inspector, and then you can have, little views. It's not just a scene view, it could be anything, data, whatever. But there are so many different ways I wanted to use this. And I also ran into, having to build a code editor. And so then, I ended up going down the route of making an extension for VS Code. And I started rewriting it so many times that most of the prototypes after this don't look as nice, just FYI, because it's like, you're just going to throw it away. Like, I can come back to this design, but when trying other things. So here's like another iteration where you can actually see in the background in VS Code a Go struct and how it's just using reflection to create kind of this UI for the component. But I'm trying to take this a little bit further than the Unity one, than the Unity model. Could components be in different languages? Could they live across processes? Could they live across machines? Some of that kind of Plan 9 ideas. And actually kind of pull some inspiration from dbus, as well as like COM and stuff. I won't get into that, but to have this like standard API, the more you put into this thing, the more you can do with your standard operations. So there's a lot of different ways you can use this. I've also been sort of aligning it with the WebAssembly component model, because you can imagine that being a way to have cross-language stuff, and it's not specific to the to WebAssembly, but I've been working a lot with WebAssembly, as we'll see in a little bit. Here's another iteration where it's kind of like built into VS Code. In this case, I was actually using it to extend VS Code itself. So here I was creating a command in VS Code. It can also be used as kind of a view model, right? So the data in a manifold hierarchy could be in a database or CRDTs or anything, but then they're in this sort of in-memory representation that you could then pass to a view. And so in this case, this actually is sort of like a this backplane was kind of like here's a view of manifold directly, and then here's the app that's sort of just like taking that structure and rendering it in a certain way to make it look like Trello. And if you were to interact with either one of these, the other would sync up, because they're basically working with the same thing. And you can kind of see experimenting with different, breaking down the data model a little bit. A card, you can do labels as a general thing. Last year, we built a kind of a Notion clone, more inspired by Tana, which is kind of more hierarchy oriented. I was like, that's basically Manifold. So here's that idea. This is powered by Manifold, or one iteration, one implementation of it. And all the functionality that this editor has is done through components in the Manifold hierarchy. So like on the right there you can see a node could have a clock. So org mode in Emacs has this, like, any node in the hierarchy, you can just clock in and clock out, and people use it for time tracking and stuff like that. It'll show the aggregate in the parent. And so that clock feature, both the UI and that functionality, is done as a component. And then you just, the UI to the user, we're saying like, oh, add a clock, but behind the scenes, we're just adding a clock component to that node. So I've been using this to do a lot of different things, I'm been also working on a lot of other stuff around this. And one of the things that came up is this project called Wanex, which I don't know how many people may have seen the demo, but I can kind of give a quick version here. So this is actually kind of, you might be able to make the connection to how this comes back to Manifold, but in a way it was a lot more inspired by Plan 9 stuff and file systems, even though those are kind of, if you think about it, the same thing, different representations of the same ideas, or could be. And so Wanex, let's go in and this is Wanex. This is a WebAssembly operating and development environment. So it works in the browser. It's kind of a, Unix-like environment as a file system. It's using IndexedDB to back most of this stuff. But there's also virtual, there's a, I think it's sysproc. There's one process here. It's the shell process that I'm in. So there's some information about it. This shell is a separate thing from the kernel. The kernel is mostly just doing this virtual file system kind of multiplexing. But the thing that actually motivated this was the fact that Go's compiler is written in Go, and Go's compiler can transpile to any platform, including WebAssembly. Is one of the first first languages to get WebAssembly support. And so I was really surprised that I could just compile the Go compiler to WebAssembly. And then I would have a Go compiler that runs in the browser that can create more WebAssembly or native binaries. And so I thought, well, it needed a file system to do that. And so just adding a couple more things, it's like, well, now I have a Unix-like environment. This bootstrapped all of computing. So let's see if we can do that again, I guess. So, I could make a Go program here. There are a couple of examples of, I guess we could do, I actually forget where stuff is here. So we have sys, shell. So in here, and just doing experiments, like instead of a bin directory, there's a command directory. If a command, so you put, instead of having a path, if it's in command, then you can run it. If it's a directory with source code, then it will compile it when you run it. Silly things like that. There's a Go editor called Micro, and so we got that to run in here. And so we can make some changes to the shell. And so that's the source that we're running. But I really like the idea of live editable systems. So being able to modify this. And in this case, though, because it's the shell, we have to reload. But it will actually notice, hey, the source has changed. So when it ran the shell, it's gonna be like, I have to recompile it. And so when it loads up here, it has that. But you could do this for any program. It has a lot of other interesting properties. You can do web apps in it. So we're in an app right now. It's a terminal app. Let's see, sys app maybe. There's a couple. Here's a to-do. Oh, it doesn't work because there's a bug where it won't work unless DevTools has been open, which is really a crazy bug. And I'll close DevTools. So to-do app. And I won't get into, and then you can pull down a visor to get back into this. Of course, these apps can not just be apps that do something useful. They can do something useful for the environment, like be another way to explore the file system. This application is just doing file system operations. Okay, so here's another. Let me go to the Wanex.sh. This is on GitHub pages. This is the website. We kind of threw together. It's really just almost out of date at this point. And I don't know if any of you have seen the net, but if we go down here to the corner, we get one of the first sort of deployed versions of Wanex was basically this admin for the Wanex website. And the interesting thing you'll see is that I'm logged in. So we can do authentication. We use Auth0 in this case. And then with that authentication, because we are logging in with GitHub, we have a GitHub access token. So we actually have a file system that is, ooh, that's never happened before, unauthorized. It might be because I need to log in again. So you can see there's a GitHub Pages branch. Here's the file that represents the, I guess this is the home page, right? Oops. I think it something about, oh, this version had a bug where it couldn't take absolute. So there's even mouse support in here. So we can save that. So I actually wrote it directly to the GitHub Pages branch, which means it's off deploying this site now. And so what that means is we've created this kind of loop where this this environment is hosted on a website, and this environment can edit that website that it's on. So it's totally self-hosted kind of system. I don't know how long it takes for GitHub Pages to do its thing, but if you look here, actually, we just had a release 0.2, which has all this stuff. You can download it as a CLI tool and just say Wanex deploy and a domain, and it will basically set up GitHub Pages and everything for you, and then you'd have your own version of what you just saw. We can run Hugo, but here, this demo actually has a lot of other cool stuff involving CRDTs and how you can have a, without having a server, a shared, almost like SSHing into the same server, but there's no server, where you have a shared file system between users in the system. Anyway, that's what I didn't have here was, one of the things that I've been trying to do is getting VS Code to run in this environment. I've been trying to avoid using web containers, which is a technology by a VC-funded startup called StackBlitz, because it's not totally open source. Is that a hand raise, or is that did I miss that from before?
That's a new hand raise, but I was going to ask you to define quickly CRDTs for people who might not be familiar with it.
CRDTs is kind of so they're data structures to model data that you can then replicate to other, replicate, that can be replicated in any order and across time, and you'll end up in a consistent state. So what that allows you to do, for example, is if you have an application based on CRDTs, you can actually work on it while offline. Those changes, it's almost like Git for data. It has those changes, and once it syncs back up, once you get back online, it can converge with everybody else, and it just sort of magically comes into a consistent state. And so it allows you to do kind of a peer-to-peer model that also allows you to do offline. I think they're calling these databases that are based on the sync engines. Linear doesn't use CRDTs, but is kind of using the sync engine approach where the data is all at the edge or on the user. So it's a kind of a nice alternative or complement to cloud architectures where you're giving the user back to giving the data back to the users, while also getting these cool properties of being able to work offline and not need centralized databases and stuff like that. Jazz Tools is what I've been working with, but there's others called YJS, which is pretty popular, and AutoMerge. The Ink and Switch guys have kind of a big implementation. This is some random dude I like working with because he encrypts everything, and then everything's key-based. So if you don't have permission, the downside of this approach is you replicate everything to everybody, so everybody has access to everything. But this is a model where you're trying to basically introduce permissions to it, so you can just encrypt everything, then replicate it, and then if you have the keys, the permissions, you can decode it. So that's CRDTs, and so we did a CRDT-based file system for Wanex, which is pretty cool. It's in one of the demos. I was going to say, trying to get VS Code to work in this environment, which would be pretty cool. I think I'm going to give up and actually use the web containers. I've been trying all these other things, but just for now, it's probably the easiest thing. But it would mean that we'd have kind of a whole development environment. And if the rest of the kind of Manifold stuff works in VS Code, then that's kind of embedded in here as well. As well as you can imagine being able to interact with Manifold through the file system. So there's a lot of cool stuff here, but man, this is all in the browser. I'm trying to bring this out of the browser as well. And so this is a recent project that I made that lets you make, kind of virtual file systems using Flask or any web framework. So kind of use your own language, use your own favorite web framework, and you can basically implement a file system. And so if you've heard of Fuse, Fuse is user space file system and inspired by Plan 9. The fuse is kind of complicated to get working. So it's like here you can just implement it using what you already know, and then you run HTTPFS to mount. It'll run your program for you, and then mount it wherever you want. And this is using Fuse, so it's kind of Linux out of the box, and then Mac if you have Mac Fuse installed, which is a kernel extension. But it turns out that there is a protocol called WebDAV, which has been around for a long time and has been built into Windows and Mac since the mid 2000s or so. By putting a WebDAV interface on this, it will work out of the box without kernel extensions across all platforms. Also, it'll just give you the option to serve it as a 9p file system if you want, and then that can feed into other things. So this is a pretty cool project, a lot more smaller in scope, but kind of cool related to these ideas. This was just released, so I'd love it if people could try this out or play with it. Same with Wanex. And so there's a whole bunch of other stuff, but I'm pretty much out of time. So there's HTTPFS I showed you. If you're interested in helping out, the Manifold, super abstract. And so it's a little harder. I think as I start this next iteration, it'll be more concrete and people can help out. But Wanex is very tangible and exists. So if you want to help out, you can probably just join the Discord and let me know and we can get you set up. You can also just try any of this stuff. Or if you don't, you could sponsor the work on my GitHub sponsors. But I'd actually more appreciate help. So questions?
Jeff, I was going to say, if you want to keep going, we're not going to cut you off.
Okay.
If you got more to show.
I mean, I can talk about a lot of stuff, but why don't we go over some questions and see what happens?
Cool. I think I'm up next.
Yeah.
So looking at HTTPFS, HTTPFS looks like a really cool tool, but it's like pretty general purpose. So I'm curious, like what kind of use cases you'd imagine people using, or what kind of how you'd like people to use it.
To do what? Yeah. The crazier, the better. I do have specific things in mind. I actually would love for people to learn about Plan 9 and how Plan 9 file system works and re-implement them and create like an adapter so that you can basically, and if people don't, I eventually will, but create, the mouse, create a network basically re-implement Plan 9 file systems using this, and then you can you'd have a cross-platform way to play with those kinds of Plan 9 ideas. But there's all kinds of stuff. People that figure out how to use Fuse have done all kinds of stuff. I remember there was one popular, I don't remember the use case, but it's just like, oh, that's cool. It's like all those browser tabs were exposed through the file system. I don't know if you could like close the tabs through any kind of system, remote APIs. Like the obvious stuff is like remote storage. That's kind of boring. If it's interacting with APIs, like create a, and I really like using Plan 9 because that's why Plan 9 figure out how to do these kinds of file systems and systems through the file system. And so, using the control file and the way they think about that stuff, I think works really well. What would it look like to expose, various APIs, web APIs through this file system, stuff like that. I don't know what else. There could be a lot of things, but Plan 9 is a good place to start.
Cool, thank you. Jordan, you're up.
Nice, thank you. So hopefully mine isn't a tangent or anything, but I actually I have kind of a very similar way of working as to the one you kind of demonstrated for us. Where basically I use kind of a NixOS, Emacs, and Durenv stack to enable kind of a very similar process for systems code. And when I was reading a description of Wanex, is that the correct pronunciation?
Wanex.
Wanex, there we go. Of Wanex, one of the things that was pointed out as an influence is Genera, which is one of the offshoots of the MIT Lisp machine operating system, which also informed a lot of my choices kind of going in to how I work. So I wanted to ask, like, what is, what kind of influences have you taken from it? And, just kind of like, if you could, a quick summary of your experience working with those old systems, because I always love to hear more about that and how it informs someone's approach.
Yeah, it's funny. Sometimes I'll say Smalltalk. More people have heard of Smalltalk,
Mhm.
but Genera felt like a little more niche, and it's cool that you've heard of it. Genera is an operating system written entirely in Lisp, and like Smalltalk and some of these other systems that I'm taking inspiration from, they are all kind of live editable. So
Mhm.
Lisp, as a programming language and environment, is interesting because there's no modules. So it's like everything exists in this. Every function that you can call lives in the exact same namespace. So you have like these really long function names, but you can call any function that and you can go and rewrite the drivers if you wanted to. Like the entire stack is Lisp, and it's a
Mhm.
graphical user interface and everything. And so it's really interesting that they have one is this like super vertically integrated, right? It's like the same thing all the way down to the drivers, and then the graphical UI. It's the same stack, and then the
Mhm.
fact that it's live editable is really cool. And I haven't found, there are probably a lot of other cool things about it because I haven't had a lot of hands-on experience with it. But I kind of pull inspiration from this kind of open architecture and allowing people to change anything and stuff like that.
Mhm.
Smalltalk though is the same way, and there's a bunch of other projects that kind of have similar things. So I'm trying to work that in a way that is um, take some of those ideals, but makes them kind of work with kind of the practical day-to-day stuff. Like you still have to
Mhm.
recompile, but at least it'll, if you recompile, it'll live reload, stuff like that. So yeah, that's about it with Genera. It's a cool project. A friend of mine had an old Lisp machine. It,
Mhm.
it was it was using a Mac, an old Mac as a host, and then
Mac
it had like
Ivor.
a daughter.
Yeah.
Yeah. Um, and uh, and so we actually had one that we could play with, but I think he sold it to uh, someone here in San Francisco.
Oh man. Oh, that's
I'm
cool.
I'm bummed that he did that.
Oh yeah. I've got something of a project going on to make Lisp machines like replicas on an FPGA to make them a little more accessible, but yeah, there do need to be more of them in the world. I would think more people should experience that way of working. But cool. Thank you for that response. That was a great summary of yeah, that was a great summary.
Genera, yeah,
Yeah.
cool. Yeah, back to you again.
Sorry, I just had a quick question about I know you took a lot of inspiration from Plan 9. Um, and I was curious if you mentioned that after the project was sunset, folks went on to work on Inferno, which was kind of like the official successor. I was curious if you found any other ideas worth, like, was there an evolution of Plan 9? Were there ideas worth adopting from there, or was it just more of a continuation of the work from Plan 9?
I actually don't know much about the Inferno project other than it was sort of a response to the JVM, and so that was kind of a different, um, a different approach to a lot of things. Like and what's exciting is that the idea of the Java virtual machine as a general idea is coming back through in WebAssembly,
Mm.
except without the Java runtime, and so that's really exciting. But it's interesting, and I mentioned COM and stuff because Manifold, you know, I've described one way to use it. Think of Manifold as like a dbus for WebAssembly, even though it's not WebAssembly specific, but really it's there's all these different ways you can use it. and I research a lot of distributed object stuff that happened in the early 90s. It's really interesting. The vision for objects, the idea of object-oriented programming was distorted like 3 times. There's like 3 or 4 different, significantly different interpretations of what object-oriented programming is. But there was at least one time this idea of, and I found old Apple, even after Jobs, Scully was talking about what sounded like an app store, but for objects or components. And I was like, that sounds really appealing to me. But some of the development of that stuff was derailed by the web, which kind of just like started over. And a lot of the object stuff kind of fell into kind of a niche or didn't continue, which was probably a good thing because there's a lot of over engineering going on. But one of the things that they were trying to figure out was distributed objects, so Corba, DCOM, and people talk about it being a failure, but DCOM would actually kind of work today. I was talking to one of the people that worked on it, and it's like it's one of those things where it has a reputation, or like people just know that it failed or whatever. But because what happened was it was a way to interoperate between languages, but it required a lot of this, like, in a way similar to what the component model is trying to do with WebAssembly right now. You have to like generate all these stubs to basically do RPC across different things. There's really no way around that, or there is a way around it, and that is to just use a common VM, which was the Java approach that Microsoft then decided to emulate with .NET, and basically do the same thing. So there's good ideas, interesting ideas about it, but Inferno, the project that came after, I don't know much about it other than it was a response to the JVM. And so I don't know if there are any good ideas there, but it felt like they maybe abandoned a bunch of the cool Plan 9 stuff.
Cool.
I don't know if there was like a direct continuation on the project.
Thank you for that. And there's just a couple of minutes left, but one more question from Zach in chat about what the future holds for the Manifold project.
I'm actually starting on it over again. One of the things that's been difficult is just trying to, it's like looking at a gemstone or something. There's so many different facets because there's so many different ways to use it. And to make a good abstraction that can be used in so many ways, you actually have to use it in those ways to know if the API is going to get in the way or whatever. And I've spent a lot of time trying to make it as simple as possible, not just for reasons of like, sometimes you do have to port it and re-implement it in different languages, or sometimes you do have to expose it over a network or whatever. So the less methods that you have to do, the better. And I think I got a little obsessive with trying to make it simple. But I guess the approach that I'm thinking about now is, I don't know how to describe it, but I'm going back to kind of a VS Code extension that is kind of defining what that particular kind of UI, a Unity-like UI, would need from it. And then the backend implementation can kind of be a lot of, I don't know how to, it's a really hard abstract thing to talk about. And a lot of it is stuff that I need to like try to see if it's a good idea. And I've kind of, even though it's roughly the same thing all the time, I've been very hesitant to write about it because I'm not sure if it's worth writing about. I want to get to a point where it's actually proving value before I take the time to write about it. But I'm incredibly excited about it, and like I said, that we have used it for some different projects, the Treehouse project, and I don't know. I'm pretty excited about this next iteration. Actually, I could say one of the things that I've wanted to do for a long time is have OBS, which is a streaming software used by pretty much everybody that does Twitch or other things. It's an open source kind of audio video mixer, and it is a collection of high performance cross platform inputs and outputs for audio and video. It supports all sources of audio, sources of video, and then you can kind of compose them on a screen into a scene, and then you can switch between scenes, and then you can get the output as video on disk or as a stream or whatever. And it's based on a library called libobs, which actually lets you string those things together without using the whole app, which makes it a very appealing kind of toolkit for audio video stuff. And I've been trying to find a way to actually use libobs. I mean, you can do it, but it's a complicated beast. But one of the shortcuts is to just there's an equivalent of Chrome DP, which is the Chrome developer debug protocol that lets you kind of remote drive Chrome. And there's a WebSocket API for OBS. And so there is kind of like a high level, easy way to control OBS. And I'm interested in basically building what I want to do with Manifold is build kits of components that you can then sort of set up and arrange in Manifold to achieve certain different purposes or build different kinds of systems that are kind of across domains. So, you not only have the OBS stuff, but you might have, you can just the idea is that you can kind of just like throw together software and software architectures. If I want to run this on a VM in the cloud, then I can create a node that is a component that represents a DigitalOcean host, and then it knows how to set it up with Manifold. So then I'm able to remotely control that Manifold in the same way that you can with like a Plan 9 file system, and run the stuff on that remote thing, or I could run it as a subprocess locally, and just kind of compose these different component kits to do various things. And that's sort of the dream, is to just have, once I've kind of proven the paradigm. Anyway, I was getting to one of the projects that I'm sort of using to validate this is using OBS. It was actually to recreate some friends use a thing called MetaStream to do remote movie nights. And it's kind of a pain because everybody has to, it lets you kind of sync video in the browser, but everybody has to have the same service. So mostly works with YouTube because that's the common denominator. And obviously you could just stream video and have everybody see it. So by using something like OBS, you could kind of build a system like that. And WebRTC is another kind of like great audio video stack for, I'm pretty sure WebRTC is being used in Zoom, but most things use WebRTC. And so being able to have WebRTC and OBS as a kit, I could throw together something that would have kind of like, it's bespoke, right? It's made for us and how we want to share movies, but then you could wrap that up as a prefab and Unity terminology, and then anybody else could create an instance of it and customize it and do their own thing. The idea is to try and make software more like working with Legos, but Legos where you can kind of take them apart and modify them and kind of customize them in a way, thinking of it at the system level as opposed to in a particular programming language or whatever. So that's kind of the dream with Manifold, and I'm starting to get into some of that now that I've figured out most of the abstractions and ways to do it. So I'm pretty excited.
Cool. Well, thank you very much for chatting with us. I'm going to provide a link of all of the projects you've mentioned, as well as your GitHub link and the Discord you had in chat.
Cool.
Yeah, thank you so much. And just so if folks want to get in touch with you, the best way is was that Twitter, that Discord link, and
yeah, where did it go? yeah, there's that. Program on most things, GitHub, Twitter, etc.
Provide that as a link in the chat.
That was awesome. Thank you.
Thank you so much. Awesome.
I'm still
Yeah.
digesting everything I saw. Yeah.
I'm
And this
gonna
is the
watch it again.
condensed. This is the
Mhm.
condensed version where it's like I'm not going to talk about all that, but I'm trying to give you something that just wash over you.
Yeah,
Um,
everybody, if we get some solid contributions in on the project, Jeff will come back and give us a round two. So
mhm.
Awesome.
Yeah. All right. Cool. Thanks for having me.
Thanks, Jeff.
Thanks for coming.
thanks,
on,
Jeff. This was great. Really appreciate you.
Definitely.
I
Have a
hope
great
to
one.
hope to be back.
100%.
Thanks,
Bye.
everybody.
Evening all.
Bye.